Hello, college algebra students. We are going to look at operations with rational expressions in this video. By operations, we mean addition, subtraction, multiplication, and division. The process that I'm going to follow is outlined here at the top. When multiplying, we're just going to multiply straight across the top, straight across the bottom, or in other words, multiply numerators and multiply denominators. When we divide, we are going to multiply by the reciprocal of the second rational expression. I'll mention what a reciprocal is if you don't remember that vocabulary word when we get to number 3. Then at the end, we're going to cancel all common non-zero factors in the numerator and denominator. So I'm going to start with this first example here, and factoring is going to be extremely important for these problems, just as factoring was really important for simplifying rational expressions. So I noticed that in my first rational expression here, I have a difference of squares in both the numerator and denominator. So I went ahead and factored those. Just wanted to let you know that there is a factoring video on the YouTube channel. So if that was particularly difficult for you, you might want to go back and watch that video. I'm going to concentrate on the multiplication here, not the factoring, although factoring is extremely important in these types of problems. From here, I'm going to, as it mentions above, I'm going to multiply the numerators together. And then I'm going to multiply the denominators together. And then I'm going to see if there are any common factors in the numerator and denominator, and I see a couple. So I have an x minus 2 in the numerator and an x minus 2 in the denominator, so I'm going to cancel those. I also notice that I have an x plus 1 in the numerator and denominator. After simplifying, my final answer is x plus 2 over x minus 1. So this is the simplified version of our answer. Now, I do want to mention that you are able to cross cancel. So some of you up here at this step might have noticed that we have an x plus 2 up here. I'm sorry, not x plus 2. How about the x minus 2? We have an x minus 2 up here. We also have an x minus 2 down here. And you're thinking, well, maybe I'll just cross cancel and then multiply numerators and multiply denominators. And that is just fine. So you're welcome to cross cancel. I went ahead and waited to cancel until the final step. All right, let's look at another multiplication example. We're going to factor here. That's going to be our first step. So I have a coefficient of 1 here. So I can come up with two numbers that add to 2 and multiply to negative 8. Those two numbers would be a positive 4 and a negative 2. That will make my factors x plus 4 times the quantity x minus 2. The denominator here of the first rational expression, two numbers that add to 4 and multiply to 3 would be 1 and 3. So I will make my two factors x plus 1 and x plus 3. Those are my two factors. Numerator of the second rational expression, to factor that, we can take out a GCF of 3, and we would have x plus 1 left. And then down here in the denominator of the second rational expression, I can't do anything with x minus 2. I can't factor it at all. Okay, now I'm going to multiply numerators and multiply denominators. I'm going to go ahead and put the 3 in front, although the order is not important. I just kind of like to see that number in front there. And then multiply my denominators. And then the last thing I'm going to do is I'm going to look for common factors in the numerator and denominator. I have a common factor of x minus 2. I also have a common factor of x plus 1. So answer would be 3 times the quantity x plus 4 all over x plus 3. Some students will ask if they have to distribute in the numerator here, and you can if you want, but you don't have to. It's not necessary. So if you would like to distribute and make the numerator 3x plus 12, you can, but it is not required. We can leave it in factored form. Okay, before we move on to addition and subtraction, we're going to do one division problem here. So the two previous problems were multiplication. Now we're going to see division. The first thing I'm going to do is I'm going to take the first rational expression and I'm going to multiply it by the reciprocal of the second rational expression. And this is something that you probably remember doing back in maybe upper elementary or middle school. Whenever we divide two fractions, we take the first times the reciprocal of the second. Reciprocal is just flip it. So I've changed this into a multiplication problem. And then from here, it's just like what we've been doing. So just one extra step here. I'm going to factor a 2 from the two terms in the numerator of the first rational expression. I'd be left with p plus 3. P plus 5 cannot be factored. Then I'm going to look for two numbers that add to 2 and multiply to negative 15. That would be a positive 5 and a negative 3. So positive 5, negative 3. And in the denominator over here, I can factor out a 4. Maybe this time I will cross cancel. I'll show you that we can cross cancel. So I've got a factor of p plus 5 and a factor of p plus 5. I can cross cancel there. Just kind of doing that before multiplying numerators and multiplying denominators. I can also cancel the p minus 3 and the p minus 3. I can also, well, maybe I'll wait till the final step here. I can also reduce the 2 and the 4, but maybe I'll wait for that here in just a second. So here's what I have when I multiply what's left in the numerators, and here's what I have when I multiply what's left in the denominators. Now there is one more reduction that can be made. I have a 2 and a 4, and they share a common factor of 2. So I can reduce just a little bit further. My final answer is p plus 3 all over 2. All right, so that is multiplication and division. Addition and subtraction can be a little bit tougher because we need a common denominator when we add and subtract rational expressions. Again, back from upper elementary, middle school, you probably remember that it is necessary to have a common denominator when you add and subtract fractions. So since our rational expressions are really just fractions with polynomials, we're going to need a common denominator. I'm going to go for the least common denominator when I add and subtract. You don't technically have to use the least common denominator, but it's going to be a lot easier to use the least common denominator. There'll be less simplifying when you're done, or when you get to the final steps. So starting with number 4 here, I want to try to make these denominators exactly the same. And so I've got a 4 and I've got a 6. I'm going to just concentrate on the numbers first. The least common multiple of 4 and 6 is 12. Now I could multiply, by 6 over 6 over here and 4 over 4 over here, but that wouldn't be the least common denominator. I'm going to have to simplify later. So I'm going to use 12, and I'm going to have to multiply this rational expression by 3 over 3. Now, whatever I multiply the denominator by, I also need to multiply the numerator by that same number. Otherwise, I won't have an equivalent rational expression. Okay, over here, in order to get a denominator of 12, I'm just dealing with the numbers right now. I have to multiply by 2 over 2. All right, so after doing that, I'll have a 12 over here, I'll have a 12 over here. The variables also need to be the same. So I notice that this denominator has an x, but this denominator does not. So I'm also going to have to multiply by x over x. This denominator has a y squared. This denominator does not. I'm going to have to multiply this denominator by y squared over y squared. I'm sorry, this whole rational expression by y squared over y squared. So 3x squared times 3x would be 9x to the third. Wow, that's supposed to be a 3. That doesn't really look like a 3. Let's make this look a little bit better. There we go. In the denominator, I have 12xy squared. Now, order is not important. I went ahead and put the x in front of the y squared, but it's okay if you want to write that as 12y squared x. That would be just fine. Just put them in alphabetical order. I just put them in alphabetical order. You don't have to do that. Then y times 2y squared is 2y to the third. And in the denominator, I have 12xy squared. All right, that is wonderful. I have a common denominator, so that's good. Now that I have a common denominator, I want to add numerators and retain that common denominator. So I'm going to add numerators. I'm going to retain that common denominator. We do not add denominators, we just retain the common denominator. And actually, this is our final answer right here, even though it looks a little crazy. I cannot reduce. If I was going to be able to reduce, then there would be a common factor in all 3 of these terms here, which there's no common factor. This one has an x cubed. This one doesn't even have an x. This one has a y cubed. This one doesn't even have a y. The numbers do not have any do not have a common factor. So that is our final answer. Okay, let's see what to do. Let's see what we're going to do when we've got not just monomials down there, but we've got trinomials and binomials. Factoring is going to be important again. Lots of factoring with these. 2 numbers that add to -3 and multiply to -18. That would be -6 and +3. So that means my 2 factors are x minus 6 and x plus 3. Then I'm just going to copy my second rational expression. Okay, now just as we did in number 4 above, we need these denominators to be the same. This denominator has that x plus 3 that this denominator has, so that's good. But I notice that this denominator has an extra factor of x minus 6. So what I'm going to do is I'm going to multiply this denominator here by x minus 6. And if I multiply the denominator by x minus 6, I need to do so in the numerator as well. Otherwise, I do not have an equivalent rational expression. All right, now my problem looks like this. I have 6 over x minus 6 times the quantity x plus 3 plus, I'm going to go ahead and wait to distribute. So I'm just going to keep it as 5 times the quantity x minus 6 over x plus 3 times the quantity x minus 6. Now notice my denominators are the same. That's good. To be able to add or subtract rational expressions, I need a common denominator. Now the factors are in different orders, but that's okay. Multiplication is commutative, so it doesn't matter that, like I said, they're in a different order. Now, once I have a common denominator, I'm going to add numerators and retain that common denominator. I'm still going to wait to distribute. The reason why I want to wait to distribute is when we get to subtraction, students make some sign errors, so I'm trying to avoid making any kind of sign error. Now, I chose to write the factors of the denominator in this order, but once again, you're welcome to write the x plus 3 in front of the x minus 6. Okay, and then the last thing I'm going to do is distribute in the numerator and combine like terms. So distribute, combine like terms. Final answer is 5x minus 24 over x minus 6 times the quantity x plus 3. All right, this video contains one more example. This one is a subtraction example. And I've got a binomial and a trinomial. I'm going to start by factoring. That will allow me to determine what my least common denominator is going to be. So hopefully you recognize that the denominator of the first rational expression is the difference of squares. The second rational expression, the denominator is a trinomial. I want to find two numbers that add to negative 16 and multiply to 64. And that would be negative 8 and negative 8. So I'm going to have my two factors of x minus 8 and x minus 8. Then, just as we've been doing in the last two examples, I need a common denominator. I notice that the second denominator has two factors of x minus 8. So this denominator is going to need another factor of x minus 8 if I'm going to get a common denominator. Now this denominator has a factor of x plus 8, but this rational expression over here does not have an x plus 8 in the denominator. And so I'm going to multiply both the numerator and denominator by x plus 8. All right, now I'm going to rewrite my problem with my common denominator. Again, I'm going to wait to distribute. So I'm going to wait to distribute. I'm also going to, in an effort to save a little bit of space here, since I have two factors of x minus 8, I'm going to go ahead and write that as x minus 8 quantity squared. So that just saves just a little bit of space. Okay, minus 2 times the quantity x plus 8. And then I've got my same common denominator. Same denominator. All right, and then I'm going to subtract numerators and retain that common denominator. Now, I always like to wait, like I mentioned, till the very end to distribute, because if you distribute at this step, you get 2x plus 16, and you might forget that this here applies to both of those terms. So it's actually going to be minus 2x minus 16 when we go to subtract the numerators. That's why I like to, if you wait to distribute, I feel like students make less errors with that sign there. Okay, finally, I am going to distribute now. It is going to be minus 2x minus 16. And I'll go ahead and copy my denominator here and combine like terms, and we're done. So 5x minus 72, and then over our common denominator. All right, so just a little recap here. When you're multiplying and dividing, you do not need a common denominator. We just multiply numerators and multiply denominators. We do have to remember when dividing to multiply by the reciprocal of the second rational expression. And then when you're adding and subtracting, you will need a common denominator. And again, I recommend that you, when you need to distribute, I would wait until the very end. I feel like students make less sign errors if they wait. All right, well, hope you enjoyed this video and hope you have a better understanding of operations with rational expressions.